Okay, so I have my Hexapod leg hooked up to a PCA. The PCA is connected to Uno via I2C. And here we can run the code to start the server. Let's see. So if we ran npm run client, this will build a client, and then here we can do a npm run server. Now it says it's connected on COM6, and we can see our robot starts up here. And I'm trying to set everything up. So here we need to reload this page. This is a simulation. This is the right leg, which is this right middle leg right here. And we can change the, here we can see we can change a lot of these things. And if we go to leg patterns, we can change alpha, which is the coxa joint. We can change the beta, which is the femur joint. One thing I've noticed is this IRL version compared to the web is actually a little slower. I'm not sure if it's the code. I really think it's the code or something, because it's lagging behind a little bit. Either that or just some type of delay that I haven't figured out yet, but that's one thing I need to figure out. The gamma is the tibia joint. So let's move this up here. And this is the tibia joint. And you can see it lags behind a little bit. It's definitely not limited by the servo speed, because these servos go a lot faster, as you can see here. Maybe it's just when I'm dragging it, that's why. I don't know. We'll figure that out later. And we have some leg patterns, we're on that. And we can go here. This is the walking gants. We can just do a triple tripod gait. The hip stance, we can see, let's see. We need to change this value so that the legs don't overlap and run into each other. The leg stance, we can make this go down, make the Hexapod go down a little bit. Its body to go down a little bit so it looks a little more natural. Hip swing. Let's take a look here, something like this. And step count, we'll keep in the middle, and let's pull this. We can see here that this is still lagging behind compared to the simulation. And when I stop this, it's still trying to catch up with the simulation. Even though this has stopped, this IRL version keeps running to try to keep up. This is more noticeable when I change the step count higher. Now I run this. We can see that this IRL version is running a lot slower than the simulation. And when I stop this, it continues to run for a bit. And so I thought maybe if I change the step count down, it would fix it, but no. It continues to run. It's about to fall off my table, but yeah. And also notice here that the leg is literally broken right here, which, I mean, there's no fillets, there's no, I feel like this design is just completely for testing purposes. And I dropped this like 3 times from the table on the floor, so I mean that's probably why it broke. But yeah, everything seems to work. Inverse kinematics, we can change the body. So basically what this does, this moves the leg, the tip of the foot, up and down in a straight line. Here, this will move, this will hopefully have the foot contact with the ground and move the body back and forth. This moves this side to side. Some pretty interesting shapes here. Yeah, we can see that when I move this slowly, it seems to lag behind. But when I move it here, say like I just click a spot, then it instantly goes there, and it seems fine. So I'm not sure what's causing this, but we'll figure that out later. But yeah, so far I'm pretty happy with this. So if I drag this slowly versus when I go fast, these servos, for how strong they are, they're actually quite fast. Yeah, you can definitely see it's like a little slow. I'm not sure. It's definitely something with the code. But why when I click it, it's really fast. But the speed I move this, you see, when I let go, it's still moving. If I move it really, really slow, I don't know why this is. But yeah, so far this is pretty cool. Oh my goodness. All right.